This is a classic shelf from a shop now with all this kind of standardized product on it. And in a way, we started to have this idea that things are made in some factories, mostly in China, where people are assembling the things that we buy cheaply from shelves. And this is the classic sort of industrial process that we sort of are used to. But in a way, there are some new technologies that are changing the world. So this is a picture of a 3D printer printing some object in plastic. And this is part of something that in a way enables different ways of doing business. Like in this case, it's a service where you can go online, you can design your own products, and then if you can customize, you can create your own exact product, and you can have them printed and shipped to you. So in a way, there is this direction where there are new technologies that are enabling different types of manufacturing. So instead of making a million pieces of a plastic robot, they make exactly one robot, exactly the one that you want. So this is one of the many elements who make this, in a way, phenomenon that the economists a couple of years ago called the third industrial revolution. So this idea that there are all these new machines, new processes, from a digital file you can create things in different technologies. But I think what's actually changing, it's not only the sort of more industrial, more professional end, but if you look at the way people come up with ideas and they produce things, the way you discover, learn, invent, fund, make, and sell your products is changing in different areas. So without going into much detail now, I think a number of people, they touched on different elements like, the Kickstarter, changing the way for Indiegogo, changes the way we fund projects, or digital fabrication makes it easy to make certain type of products. Learning is disrupted by all these online services and so on and so forth. So in this kind of changing landscape, the work that I've done in the last 10 years is working on this little thing here. This is the size of a credit card, just to give you an idea of the size. It's a small computer that I designed with a number of friends as a tool for designers to be able to make prototypes of products. So the idea that you can prototype with technology and that you can create tools that are available to a larger audience. So it's interesting when you're looking at technology, if you start to move away from the professional and you start to look at how do I build things for somebody that has no background, a lot of assumptions go out of the door. So if you say, some people are interested in what kind of programming language is running on a certain computer. A beginner doesn't even know what a programming language is, so he or she doesn't care what's running on the circuit. So the question is that you have to start to look at things from a different angle. And so we created this system where you have 4 different parts that are very important. So the hardware is important because people can feel and touch the circuit. But what's really important is to create a system where you have the hardware, then you can see in the top right corner there is software, the software that you use to program the circuit. So doing electronics has become a lot simpler in the last few years, because in the past, if you wanted to create a circuit, you definitely had to be an expert. You had to use individual components, and you would create a circuit that would have one or very limited functionality because it was custom made to do that. And then as digital processor becomes simpler and simpler, what happens is a lot of the complexity of how a certain product works shifts from the circuit and how the components are connected together, shifts into the software. So this means that with one single board like this Arduino, you can load an infinite amount of software, so you can create an infinite amount of products, because a lot of the logic, a lot of the core of the product is in the software and not anymore in the way you design the circuit. So this enables people to shift the the knowledge from being an electronics engineer more towards programming, which is a little bit more approachable in certain points of view. Then the other thing that you need, and this is the bottom left corner, it's a methodology for teaching people, which is based on making stuff, it's based on learning by doing. You know, when I started teaching my students, I started teaching using the way I learned in university. So where you sit in a room and there's somebody with a presentation that goes on forever, talking about very theoretical stuff, where you always have a problem trying to understand how that connects with your life. And so when I tried to do that with my students, they lost interest in exactly 3 minutes. And you could see everybody was opening laptops, browsing. So I realized that this is not the way I learned. I learned as a kid by playing around with stuff, by taking apart things, by trying, you know? So one of the things that in those days was like this: if you built something and it didn't explode, there was no smoke, then you learned something. I mean, also when there was smoke and fire, you learned something. You learned not to make the smoke and fire. But in a way, you combine the hardware and the software in the way to teach, the way to approach the subject. And then the last element, you can see that's the old Arduino website, is the community. It's incredibly important to build around these products a community of people that interact, help each other. So somebody mentioned in a panel before that when you try to build something with Arduino, you can actually go on Google and type, I don't know, I need to build a space shuttle with Arduino, press a button, and there is an article somewhere that explains how to do it. So these 4 elements are really the 4 pillars that make Arduino what it is. But one of the elements which is not so obvious is also the fact that we released everything. So the software, the hardware, the documentation is open source. So we were one of the first projects to release the design of the circuit open source. This allowed a lot of people to learn by copying our design, extending our design, so it became a very popular type of technology because it was open. So in a way, this ability to create this community of people that are doing DIY to create something new is based on the fact that you have to give them platforms, and these platforms need to be open, and they need to have open channels of communication so that they can communicate with each other, they can share the knowledge. And it has to be designed in a way that you could teach this to a child. This is Sylvia, and she had a show on YouTube where when she was 8, she was showing how to assemble circuits with Arduino and LEDs talking to each other. So, but in a way, you talk to different audiences, but in a way, you have a big community that fits with everything. And then it's interesting to see what the community is doing with the technology, because I'm going to show you a number of examples. They're quite rough, they're not finished product in most of the case, but then a lot of these are evolving into people actually understanding they can build something, that their idea has some kind of a value. And it was designed originally for my students because they were making a prototype and then they had to interface with a factory, interface with engineers, and they needed a prototype to validate the fact that their idea could be built. And in a way, the community took this aspect and expanded that. And then you see communities popping up all over the world, helping each other to learn and start making stuff. So this is the example I mentioned for the ones who were in the panel. This cat feeder is one of my favorite projects because it feeds this cat that has a chip around the neck. So the food contains a medicine, so only the cat that has a sickness eats this food. And this is made by using a CD-ROM reader, like an old CD, using to make the automatic opening door, a couple of sensors, an Arduino, and cardboard boxes. So this is the kind of stuff that you have an idea, and in a few hours you can execute. The ability to sketch with electronics is very important because in a lot of creative processes, people need to sketch. When you have an idea, sometimes you take a piece of paper and you sketch on the piece of paper the idea. And the same thing you can do now with software. There are a lot of software development environments where you can sketch an idea and have a program running very quickly. The same here we were trying to do with hardware, to sketch a hardware, so a piece of electronics, to see if a solution is feasible. And then what happens is that as people start to create different projects, they use, for example, the Arduino technology to create other platforms that help in other directions. So, for example, one of the communities to adopt Arduino was this community of people making these quadcopters. So this is it's a kind of an helicopter, not a big one, a small one, which is powered by electricity, can be controlled remotely, but there's a logic, there's a computer based on Arduino inside this one that keeps the helicopter from crashing. So in a way, in order to fly properly, it needs a computer. Then the human operator can direct the computer, but it needs in a way the computer to keep the thing in the air. So they started to build a number of these, and then they started to make them available for cheap for people that wanted to build them for fun. And then in the end, what happened is that a number of people found that there was these quadcopters that could be bought for cheap, and they started to imagine applications for the quadcopter itself. So in a way, there's, for example, a startup that's been working for a couple of years now on using these quadcopters to deliver some types of goods in villages in Africa, for example, so to automate some transfer of important materials, but people use them with a camera to fly over something and shoot videos for inspection, for inspecting crops and for agriculture. So in a way, the people who buy this and they use it don't even know that there is Arduino in there. But this is like a second layer on top of the work that we do on Arduino, is this platform. Another platform that became very popular is the fact that 3D printers, these devices that can print an object out of plastic from a file, have been used in industry for the last 20-something years. But then, as the patent started to expire, some people, starting from the RepRap project, started from a professor at the University of Bath, started to try to create one of these 3D printers that you could assemble and create yourself. And they started to use Arduino as the motherboard. So a lot of the 3D printers of this kind, this is Ultimaker, it's a Dutch printer. A lot of these printers of this category, they still contain either an Arduino as the motherboard, or they have a circuit which they have derived from an Arduino. So again, the Arduino as a platform for creativity has given way to people to create a 3D printer that becomes a platform. So for example, I saw somebody who created a robot that can mix drinks. So you press a button and it makes a martini, or press a button and makes a Negroni. The electromechanical part inside the cocktail making machine is essentially taken from a 3D printer. So the knowledge of the 3D printer as a platform. So you have to understand that every time you produce these kind of platforms that are open and easy accessible, you get this layering. So each platform builds upon the other one, and knowledge starts to kind of build up and becomes another type of tool that people can use. So there's a lot of innovation happening in the small-scale printer because of this availability of the technology and the fact that a lot of these printers, like this one, are still open source. So if you want, you can go online and download all the files that you need to make a printer like this.